Hello, today we're going to look at a related rates problem dealing with the area of a triangle, but not the area we're familiar with in geometry of 1/2 base times height, because as you can see on this triangle, you can't really see what the height of this triangle is because you need a perpendicular segment and you don't see any right angles and you can't assume that that's a right angle. So we need to come up with the other formula from our pre-calc course, which deals with trig. Area of a triangle is 1/2 AB sine C. Some of you may remember that, some of you may not. Let's put that in our notes and make sure we can recall that formula. All right, we know that we have two sides of a triangle are 4 and 5, and I want to stop anyone from thinking the third side's got to be automatically 3. I know a lot of us are used to the 3, 4, 5 triangle, but remember that is a right triangle and we are not guaranteed that this is a right triangle. So if your initial instinct was 3, like mine was, stop that and say, nope, wait, this isn't a right triangle. I don't know what the third side is. All right, and then it says the angle between them is increasing at a rate of 0.06 radians per second. So since we know it's a rate, we know it's a derivative, and it's the derivative of the angle. We're just going to call it theta. And it's seconds, so we're taking the derivative of theta with respect to time. It's increasing, so it's positive, 0.06 radians per second. Okay, we want to find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi thirds. Okay, so we're looking for the rate of the area of the triangle, and we know it's increasing. So we're looking for dA dt, and because it's increasing, we know it should be a positive number. So we're looking for that when we know theta is pi thirds. Okay, I'm going to adjust my formula a little bit to deal with our actual angle here. So that angle C is really our theta. Okay, so if we're looking for dA dt, we clearly have to take the derivative of our area formula. So what we need to look at is plugging in our numbers because they tell me I have a fixed length of 4 and 5 for two sides. But I do not know what my angle is. It's changing. Simplify this a little bit. 4 1/2 times 4 times 5 is the same thing as 10 sine theta. And now that we've got our formula, let's take our derivative. The derivative of our area with respect to time. So we first take our derivative with respect to theta. So you have 10. The derivative of sine is cosine theta. And then you take the derivative of your theta with respect to t. So we just tag on d theta dt. Last thing we do is plug in the information we know. 10 cosine pi over 3. And we know d theta dt was the 0.06. So times 0.06. Okay. Go back to our exact values. Pi over 3, hopefully we remember what cosine of pi over 3 was. If you don't, you need to draw out your triangle. It's a 60-degree angle, and cosine of 60 is 1/2. So cosine of pi over 3 is 1/2. Multiply those numbers together. So 5 times 0.06 is going to be 0.3. Again, because it's area, we know our units should be now squared. So I have meters per second. You could also use the idea of your units coming from when you're multiplying, you'll have 10 meters, and then this will also be meters, and so then this is meters per second. And this is meters, so you have meters times meters, which is meters squared per second. And so we have our final answer is 0.3 meters per second squared.